we will be talking about Jenkins. Who here has already used Jenkins? Hands up. Quite a lot. But who had opportunity to work with a pretty recent, this year version of Jenkins using pipelines? A bit less. Okay, so if you already did, maybe you probably won't learn anything new in this talk. But if you didn't, I hope to introduce you to what has changed in Jenkins. So there were some hands not in the air. So let's say a bit about what Jenkins is. It's actually a automation tool, mostly used for CI, continuous integration. It's a free software, MIT licensed. It's meant to be self-hosted, as opposed to other popular tools like Hudson. It's pretty much made to be run in your own data center, on your VPS, and administrated by yourself, your company. It was originally called Hudson, and later, when Sun has been bought by Oracle, the project forked and Jenkins was created. Actually, there are a few perspectives on why and how this fork happened, because Hudson project says that Jenkins is a fork, and Jenkins project says that old Hudson is a fork. Because when Oracle bought Sun, they decided that this little Hudson project that they have is worth doing something more with it, like trademarking and making some enterprise versions. And as it was a free software project with quite active community of active community, they didn't like that change in how they treated the project. There were a few months of talks of how to proceed with trademarking, etc. And it all led to a decision that the Hudson community will change name to Jenkins and still continue developing the project. However, Oracle didn't stop developing their Hudson version. So actually, Hudson changed name to Jenkins, but old Hudson was still there, and so the fork happened. And later, actually, a few years later, Oracle gave away the Hudson project to Eclipse Foundation. So I think Jenkins is the project that actually won this all forking stuff, as it maintained its active community and was simply more popular. So Jenkins is great for automating repeatable tasks. It pretty much does just that. You define some tasks that are meant to be executed at some specific time or after some event, like pushing code to your repository, and Jenkins does it. That's what you want it to do, what you configure it to do. And it also allows you to get some data back, like test results, like test coverage, like historical data on how builds failed or were successful and stuff like that. It was originally meant for Java projects, It was mostly based on Maven, but as it's greatly extensible, sorry, it quickly got extended into way more technologies, way more stuff. There are plenty of plugins that you can install in Jenkins and use them in your projects. Jenkins also has quite nice support for distributing your builds. It has a master-slave architecture where you can simply add new slaves to your running Jenkins instance and distribute builds on all those other machines. So just your typical Jenkins task as it was used, let's say, still a year ago, and probably is still used. Typical role of a Jenkins task is to first check out the repository, get the code, then run some build, get the application to the proper state, run some linting, check if code is right, check if all the tests are running properly, then analyze all those results, make some nice charts, maybe send out some notifications. Things like Slack are getting very popular, already are very popular, and so you can also use Jenkins then to trigger all the external stuff that are meant to happen when you run your build. And also those tasks are commonly used to actually deploy stuff. But old way of how Jenkins managed the tasks has a few problems. And the first one, the most important, I think, is that that actually all this configuration is completely separate to the code base. It gets quickly out of sync if you change something in how you build your application. You have to maintain the Jenkins configuration in sync, and that prevents you from, for instance, simply running all revision on Jenkins to build, because if you change the configuration and it's not compatible, then it simply won't work. Also, you have to click stuff to actually configure it. It may be an advantage, it may be a disadvantage. There are quite a lot of configuration options, and if you install plugins, then it gets quickly complicated. So not versions, as I already said, it's because it's separated, and it's job-oriented. I'll return to that point later. So that's the screenshot of your typical empty project that you would just create on old Jenkins. It has a bunch of checkboxes, and this is empty. There's a button add build step, and if you make a lot of steps, then it gets way longer, and actually when you use it on some complicated and advanced code base, it gets pretty hard to maintain. Of course, there's also an activate Chuck Norris button, because who installs Jenkins without installing the Chuck Norris plugin? So that was it if it comes to the introduction to old Jenkins. Around April this year, Jenkins 2.0 has been released. And big, awesome breaking changes just weren't there. It was completely backwards compatible. Got some minor UI changes, like this configuration is now neatly separated in tabs. It's easier to maintain. So this release was pretty much like Linux 3 or 4, where Linus Torvalds just decided that numbers are getting too big and it's time to reset the counting. But it doesn't mean that there's nothing exciting there, because around Jenkins 2, in both earlier and next few versions, Jenkins team has been working on very potent stuff called pipeline. That's actually how the internet looks, if you ever wondered. So pipeline has been distributed earlier as a plugin to Jenkins, as most of the stuff there. But with Jenkins 2, they actually started to bundle those plugins together with official installation. So it got promoted as an official Jenkins feature and is now simply maintained as such. What does the pipeline mean? Pipeline makes the configuration, turns the configuration into code. If some of you worked with Travis, you probably know the Travis files and how it works. This is pretty similar. You create a file called Jenkins file in the repository. That's actually not the requirement, but it can be done. And what's very important, what I personally really like from what it means, is that when you have your code on service like GitHub, where you have a bunch of small repositories, Jenkins can easily scan all your account, all your organization, and all the repositories, all the branches for that Jenkins file, and simply automatically create a proper job for any branch you actually want to have in Jenkins. So I earlier said that the old freestyle type of tasks were task-oriented. Pipeline is process-oriented as opposed to the old ones. What that means? In old tasks on Jenkins, you wanted to do something when something happened. For instance, periodically or when code was pushed. You had a bunch of stuff you wanted Jenkins to do one by one. However, pipeline is process-oriented, so you don't actually run a task, run a build, but you start a process that consists of a lot of smaller tasks. Also, it helped greatly with making all those tasks distributed better. And pipeline is Groovy-based. You write code in a Groovy-based DSL, domain-specific language. And I personally dislike that language, but mostly for its syntax, but I'll return to that. And pipeline runs on so-called lightweight executor. In old Jenkins times, each task was always occupying one executor on some machine. You had Jenkins nodes. Each node could provide a number of executors, and when you run the task, it simply looked for a free executor and launched the task there. pipeline doesn't use those executors actually. The code you run in this Jenkins file is by default always launched on the master node. It doesn't wait for any free executors. It's organized in so-called stages and nodes. Stages are there just simply to give you a visual feedback of what happens. You can define a stage and then simply see visually which stage took how long, where it failed, and stuff like that. But more interesting is node, and it actually connects to what I just said about executors, because when you run your code always on master, always without those executors, actually just not waiting for them to free up, then you might end up with a situation that you simply do too much work on master, and it won't have enough resources to do that. So you actually don't do any any stuff that takes any time or any resources right up in the root of Jenkins file. You create nodes, and node is actually the thing that occupies the executor and is executed on neatly on every Jenkins node that's there. So in this pipeline Groovy-based DSL, you simply type node, enter the block, and then define what's happening here. It's just checkout, probably from Git or however you configure it, and then some Maven clean install. You can also specifically request some node with some specific feature. You can label the nodes. And then, for instance, here we are requesting a node that has Maven installed on it, because some other nodes maybe are, I don't know, Windows-based or something, and there are no Maven because they are used for something else. So in this way, we are sure that we'll get a node that has a Maven tag on it. So thanks to pipeline, we can easily do stuff in parallel, as in the old freestyle jobs. It was pretty hard to do, because when you had some job defined, when you actually wanted to trigger other stuff happening from them, you had pretty simple choices to do that. You could run another task when one task ended. You could trigger by the URL with some curl or wget execution of another task. But when you actually wanted to have stuff like converging process that first check out stuff, then maybe does backend and frontend stuff parallelly. In parallel, then you wanted to synchronize it somehow, you had a pretty hard time. And now it's as easy as just defining a parallel job where you can stuff simply is happening at the same time. Don't forget to allocate nodes inside. As of course parallel execution on without the node can be pretty hard on your servers. So it also allows to nicely organize everything that happens in your process, as all the steps that are defined in the Jenkins file can be shown on a graph just like that. And then you can get a feedback from what went well and where things went wrong. quite an important feature of pipelines is also stashing, as with all this parallel execution power that you just got, sometimes you have to organize what files end up on which nodes. As you can have a task for building the binaries, and then some time later you can have tasks for testing them actually, and you those don't need to be executed on the same computer, on the same node, in the same workspace. So you have to somehow move those files, somehow store them, and then restore when you actually need them. So this is just what stashing is for. Right after you get something, some artifacts, anything you want to store or use for later, you just stash it, define the name, and optionally some excludes or other options. And then when the time is right, you simply unstash them. Stashes, as opposed to artifacts in Jenkins, as some of you might probably know them, are local. They are just for this one pipeline execution, so they are better suited for stuff like testing the binaries generated earlier. Also, pipeline is very extensible in a way that you can simply write your own functions in Groovy that you want to use in your project. You can pretty much define your own company-wide domain-specific language to use in your project. And there are two ways of how you can extend the pipelines in Jenkins. You can define them as system libraries. So they are available for every project on your Jenkins instance. There's also a sandbox that restricts what the pipelines can do, which is pretty handy when, for instance, maintaining some free software projects or getting some outside contributions to your repository, as we don't really want anyone pushing to committing any branch with rogue Jenkins file to break our stuff. And when we do system libraries, sandbox is disabled. So this is for like our trusted stuff. And there are also project libraries which are defined in the specific projects. They are available only for that project. They run within the sandbox. And they are great for like some libraries that you simply found somewhere and want to use in your Jenkins file. I haven't said, but libraries are simply some repositories with code meant to be used by pipelines. So you can define a function in just a simple Groovy file. On the top, there's a path. All your globally visible variables have to be in this directory. And this is a very simple function just meant to run something in a Docker container. We are using pretty much the Docker for pretty much everything when building our stuff, as it makes it way easier to get new nodes and Jenkins nodes running. You don't have to install everything. You just get the pre-configured image, and you can, as I already said, build your own domain-specific language. This is an excerpt from a library we use in our project. Pixar is like a code name of the project. So here we have defined a bunch of functions like job, pixel build, pixel node, hub build, docker build, and sonar. It makes it easier to do stuff that are common alongside all the repositories. For instance, managing the notifications, managing the way the app are built. Like I said, we have a common way of using Docker, and then also Habitat to actually produce the artifacts. So it's all abstracted in the functions we have defined. Thanks to pipeline, there can be lots of them running simultaneously, and then they can be extremely long running. It would be hard to imagine old style Jenkins job running for weeks, but it may be common with pipelines. Pipelines, thanks to that lightweight executor stuff, can be blocking. They can wait for some stuff to happen. They can ask for acceptance, for instance. Here's an example code for doing just that. They can also ask for more advanced input, like some input boxes and stuff like that, which is great for defining continuous delivery process, like getting stuff tested, getting proper acceptance from QA teams and stuff like that. And the pipeline can actually manage the whole process from the very beginning of pushing the code to the repository to the very end of deploying it through all the environments to the production. So there are a few of gotchas. I already mentioned the syntax that I don't like in Groovy, as when you Groovy is very accepting and tolerant, which is nice when you're a human, but not very nice when you are a programming language. As there was earlier, it looks pretty much here like Bash with some blocks. But that's not a true understanding of it, because Groovy simply allows you to omit any parentheses that don't make the code impossible to parse, impossible to understand. So it's simply here. Checkout SCM is simply a function call to function called checkout with one argument SCM, which is some object, and that can be confusing. Because if you don't know Groovy, of course, earlier, because it pushes you into the great loop of fix commit push test, fix commit push test, especially when you're defining your library, you cannot really test your stuff right away. You have to have your changes in some repository, so you simply do things, commit, then look if it worked all right, and then push them again, fix what you notice that that doesn't work and stuff like that. And also, at least when you do stuff used only by yourself, you have to remember about sandbox. It's a very handy feature in some cases, but sometimes it can be annoying. And I spent some time fighting with it before I discovered that those system level libraries can be used to actually disable it. So yeah, about that loop, this is excerpt from commit log to the pipeline library we did. Of course, it was later amended, but it was a huge mess. So that's something that actually could be done better. You can have like some simple pipeline job for testing specified in the UI in Jenkins, just creating a job and then writing a code there. But as soon as you want to test stuff related like to GitHub repositories or pull requests, then you have to switch to the repository, which can be painful when you're just starting and testing out what this pipeline stuff is. And at the very end, I wanted to mention that there is a project ongoing in the Jenkins community. It's called Blue Ocean. And it's basically a new user experience for Jenkins, which you can already try. It's in very alpha stages, but it can be installed in a way that doesn't influence any old UI that's there. After installation, it simply adds a blue button on top. Try the new UI. Which lives in a separate URL, so you can even launch both of them in separate tabs. It's pretty well designed from UX side. It's very incomplete at this moment, but the slide with this pipeline graph actually was from this Blue Ocean stuff. So it already can be useful. So I encourage you to try, and that would be it. Are there any questions? Then you are welcome to ask. Thank you.
Do you have any questions? One or two questions. The first one is already.
If this process consists of lots of small subtasks, what about the persistence? If something goes wrong in the middle of the QA in the first week, can it be resumed? And does it have any memory about what happened before the crash? So we can resume the part of the process, not start from the beginning.
You mean crash situations where like Jenkins is restarted or something like that, yes?
Yes, like a week of testing, and in the 6th day something goes wrong with the 90% of the tasks being done. Yeah?
Yes, so it is handled. All this node stuff actually is meant specifically for that. When you have a node allocated and you do some work there, it won't be resumed from the node inside, as it would be hard to actually maintain some persistence there. But when we are looking at the nodes themselves, they are properly saved, properly assumed, and all the long-running processes, long-running pipelines can be safely continued.